This is ongoing research and has been submitted to the CIO as a poster, a work in progress poster, by Zhichao Zheng, Ava Fatah Gen Isricht, and Petros Koutsalapoulos. It discusses a low-budget device that was designed to replace the visual mechanism in the body by moving the device position and change eye position. It consists of a USB webcam, a MacBook Pro. You can see that MacBook Pro is number 6, and a VR headset, number 1. And the webcam was used to replace human eyes, and it was driven by a piece of code in processing, processing.org, running on a MacBook Pro. The images from the webcam are transferred through HDMI cable to a screen, which was used as a visual interface, number 2. And the VR headset, number 1, was chosen to provide immersive visual experience to participants by limiting their vision to the screen that is displaying image from the webcam eye only. So the study started as a main entrance of the Bartlett School of Architecture, I believe, yes. Oh no, it's 140 Hempstead Road, so it's a different building, I believe at UCL, and ended at the outside at 132. So this is 2 interconnected buildings just beside Euston Station, if you're familiar with London. The chosen site is the former building for the Bartlett, and it is very complex building. Yeah, I know that, I've been there, which consists of two floors that locate in 2 separate buildings connecting through a zigzag corridor. Each building has many turning points to make decisions. So the approach and data collection is related to the position where the participant is, or the subject is in the experiment. So the positions were chosen deliberately. So we can see that at H and L and H and B had the same eye level with a deformal eye, but facing different directions. So you see the body RUF and the bod, sorry, the bod RUF had the same facing direction, but was located out of the main axis of the body. And the BOD RUR differed in both facing directions and location, because most participants were right-handed, which is in the right arm instead of the left, to interrupt the most of the habitual body movements. A series of 4 eye positions were tested by groups of 37 participants. Through systematic observation and data analysis, the body movement was studied, and they've collected some qualitative and quantitative data using methods, and I believe here some of the qualitative data is shown. So this is about movement analysis. And after the eye position was changed, the usual spatial cognitive process was challenged. So we know this has an effect on how the hippocampus is encoding space. And the speed of spatial cognition slowed down. Yeah, this is expected to rematch what they see with the Bartley behavior. Participants started to use unusual body movements, applying various strategies with the hands and feet. Some of them even step into space that they rarely entered in their normal eye position. And the speed of spatial cognitions slowed down, but also varied in rate. So here we see some elements of the eye positioning, and the conclusions that a visual perception dominated assigned by proprioception. 3 learning phases were observed. Each phase had its navigation strategies with the corresponding strategy patterns. There was an arousal phase, strategies to understand the current eye position, An adaptive phase is strategies to rebuild coordination, and there was an applying phase, a strategies to navigate efficiently. So these are the conclusions, and this is the bibliography. And you can see that there is some previous work from David Kirsch, and I suggest to go through that. And we thank you very much. We hope that Ava recovers speedily.